Okay, we are live. Do you want to go over part one at all, or
Um, mm, I don't know. Not there wasn't anything on there that was too um I don't know. What am I trying to say? I think I understood most of it.
okay?
Um, my biggest question is kind of your biggest question. How do we find out the population mean? So I guess we'll find out, hopefully.
Okay. Alrighty.
But yeah, if you want to, we can just
Go to
start on
two.
part two. I haven't looked at it at all. Have you?
A little bit.
Okay. Well, hopefully not too horrible. Um, my biggest question is kind of your biggest question. How do we find out the population mean?
Yeah. Hopefully we figure this out.
So I guess we'll.
Um.
Am I echoing?
Alrighty. Maybe a little.
Yeah, if you want to, we can just
Go to
start on
two.
part two. I haven't looked at it at all. You? Do
A
you hear
little
that?
bit. Okay, we're on some sort of loop.
Yeah. Let me, horrible.
Okay, what's going on? We're on some
My,
sort of
my,
weird
my
loop.
biggest question is kind of your biggest question. How do we find out the population mean? Try muting your microphone for a second.
Hopefully we figure this out.
I guess we'll.
Um.
Do you still hear it? Can you still hear it?
No, it stopped.
Can you still hear it?
Now I heard you again.
Okay, I'm gonna. There you go. Can you hear me now?
Yeah, I can hear you now.
Okay, and no loops.
No. No, it stopped.
Can you still hear it? Okay, I'm gonna. Here, I'll hang up and then get back on. And then if that doesn't work, why don't you try hanging up and getting back on?
Okay.
There you go. Can you hear me now?
Yeah, I can hear you now.
Okay, and no loops.
No. No, it stopped.
Can you still hear it? Okay, here, I'll hang up and then get back on. And then if that doesn't work, why don't you try hanging up and getting back on?
Okay. Are you
Yeah,
back?
I can hear you now.
Oh, great.
No loops. No. No, it's
Can you hear me?
I can hear you, but we're still looping.
You're only loop and then get back on. And then if that doesn't work right
Okay, I'm gonna send you the link back.
Okay.
Why
I'm
don't
gonna
you?
hang up.
Okay.
Okay. Are we good now?
I'm scared to talk, but I think so.
Okay. Let's try this. Hopefully that got rid of whatever it was.
Yeah, hopefully.
Okay. So question 1. What are the requirements for creating a 95% confidence T interval?
Okay, so 95%. So what are the requirements?
Mm-hmm.
Um,
Okay, it says we assume that the individuals chosen to participate in the study represent a random sample from the population, and X will be normally distributed because the sample size is large.
where's that at? Sorry.
If you go to step 4, do you see that?
Under the body temperature?
Yes.
Yeah, I see that now.
That's it. So basically, random sampling and X will be normally distributed.
Oh.
Sound correct?
I thought that was the requirements to do a hypothesis test. So if we're creating a confidence interval, that's pretty much the same thing.
I guess.
Yeah. Okay.
Yeah, if you look on the answer page, that's what it says. Random sample and
Yeah.
X is normally distributed.
Well, okay.
I guess.
Good to know. Same requirements. So, and I guess we're kind of doing the same thing because you have to figure out the confidence interval to be able to do a hypothesis test.
Right.
Okay. With the data above, create a 95% confidence interval to estimate the mean age of clients who buy investment property. Input the numbers computed in part 7. Number 7, into confidence interval formula. The t-score. Okay, so the formula we are going to use for this one is not the t is equal to x minus mu over our sample deviation divided by the square root of the number, right? Or wait.
I would say it's the same we used last week, isn't it? Or Monday? The plus or minus, right?
I don't remember that formula off the top of my head. Let me look at it. Yes. To find.
Because we know.
Yes. Yeah. I agree.
Okay.
I just had to actually find the formula and
Just making sure we're on the same page.
okay, so our mean was 46.
Mm-hmm.
Point something.
I'll find that formula again.
0.73, and then our standard deviation was 8.82.
Mm-hmm.
Sorry, 827.
Mm-hmm. I got 8.82, and then it goes on.
Did I say something else? I'm sorry. That's what I meant to say.
Okay. According to the answers, it says 8.83, so I guess we'll use that one.
Okay. So x minus t-score, which is 2.1448. Square root, and our sample size is 15. Is that right?
Yes.
Okay, so 41. .50. Okay, so I got 41.112, and then 50.88.
Let me do this one more time.
Ooh, but that's not the same as what it has in the thing. So let me... Oh. Just kidding, I got 51.62. And
See, and I'm getting 42.26. What am I doing wrong?
what are you using for the mean?
46.73.
Okay, and then your
I'm doing 46.73.
and the t-score?
What?
What are you using for the t-score? Are you using it all 4 decimal places or just 2?
I'm doing the 1.96. What did you do it out to? 1.9.
I did it at 2.1448
Huh?
for the t-score.
Okay. See, and I'm not. So what? Okay. So if we do. Okay, I got 4.184 or 41.84, which they have rounded up down to 41.8.
Mm-hmm.
Okay.
I got the same thing you did.
Plus. And 51.6 on the high side.
Yep.
Okay. And then we're going to do a 99%, right?
Mm-hmm. And then the t-score is that last little bit. Oh.
What? Did you get 39.9 for the low side on that one?
Yep.
And 53.5 for the high side?
Yep.
Okay.
I'm just trying to figure out how to do the the confidence intervals with SPSS. I didn't look at that yet.
Yeah, I didn't have a chance to watch his video either. I've got SPSS pulled up.
Oh, is it in his video?
Well, in the I don't know about in his video, but in the videos that accompany the book,
Uh-huh.
it's got one that's supposed to show us how to use SPSS. I just haven't had a chance to watch it yet.
Let me see. Oh, it is a YouTube one.
This is supplemental video dealing with SPSS commands for inference for one beat sigma. These are the three commands that you should know in SPSS for one sample or one beat sigma. First, we have to deal with the explorer command. We've seen that before, but I'll cover it.
Do you want to pull it up on our Hangout?
Okay, how do I do that? Just wondering.
So on the left side of the page, with all those apps, if you go to the three dots, it has more apps, and I don't know if it'll work to do a YouTube video. I remember doing them before, but I don't remember if they work super great or not.
Okay.
We don't have to. We can just...
Yeah, I don't see them on there. Can I look it up? Search for them, maybe? YouTube. You know what I find funny is that so much of our stuff's on YouTube, but if you're ever using the church internet, like if you're at, say a steak center or something, you can't pull up YouTube.
Really?
The church filter blocks it.
What? So I'm trying to pull up YouTube, but it's not working.
Okay, well, I got this one.
That's okay. I'm gonna look at it on YouTube and speed it up a bit. So maybe
Okay.
catch something out of it real fast. Just...
Then also cover the one sample C and SPSS. And then finally wrap it up with the experience with C with the Explorer. What I'll be doing throughout this is use the blocks. So for instance, if I want to do the Explorer command, this will analyze the services. I'll take something body temperature field. And then if I wanted to, here you can actually do a confidence interval. You can press low confidence, so I won't worry about that. So you can do that. Also, if you need to use on that as well. But then the main thing when there's a clause, click on clause, you get this here. But also the main thing is to get
Is that a good what?
I think so. I think from what I just saw.
Okay.
I don't know. Oh my goodness, it's so easy. So yes, it's a very good one. So in order to change your level of confidence, do you already have the data already put into SPSS?
I do not.
Okay.
I can do that real quick.
Yeah, you do that, and then I'm gonna check and see if this actually is exactly what we want to do. Might open so, but oh, totally is. If you want, I can read the numbers off to you if that would help you.
Oh, I'm good. I'm just getting
Okay.
caught up here. Mm-mm. Okay, so I got them all in there.
Okay. So all you do is go up to Analyze, and then in Descriptive Statistics, go to Explore.
Okay, so we're pretty normal.
And
Okay,
then you're just going to make sure that your thing's in the dependent list, and then click Statistics,
okay.
and make sure that Descriptives is checked. And then right underneath that, it says Conference Interval for Mean.
95%.
And then later on, you'll just go back and change that to 99% and run it again. And then it shows up in that descriptives box category thing.
Oh, so the lower is 41.8449 and the upper is 51.6218.
Which is what we got.
Cool.
I know, right?
And then if you go back to that, what are you doing, Zach? And we're doing 99. Sweet.
I know, right?
Okay. Okay, so margin of error for the confidence level. How's the margin of error of 95% confidence interval compared to the 99% interval?
It's
Well,
bigger. Well, the what is it? The 99% is a larger margin of error,
right.
and that's the same reason as what we talked about on Monday, right?
Right.
That I'm so fuzzy on, but I'm willing to accept.
Okay. 6 looks interesting.
Oh, yes, it does.
Rather than estimating the age of his clients to buy investment properties, the realtor agent would like to test the claim that the age of his clients is different than the national average of 47. Excuse me. Use the 0.05 as your level of significance. Follow the following steps, a sequence of steps. So null and alternative. Null would be average age is 47. Alternative is average age is not 47, right?
Mm-hmm.
So then we have to figure out our t value, right?
Is that what it's referring to here, or is it referring to the z-score still?
Well, it says test statistic. I thought test statistic was a t-score.
I don't remember that. I remember before them talking about test statistics, like from last week, and that
Yeah.
being the z-score.
Statistic. Yeah.
But upon doing a search of test statistic in our thing, it sounds like the t-score is also a something, or the t. Yeah, the t-score.
Okay.
And we've it's
So
that
if
first.
you look on the answer page, it's asking for the t-score.
Yeah. Oh, okay. But the t-score formula and the z-score formula, the only difference is instead of using the population standard deviation, you use the other one.
Mm-hmm.
Oh man, my calculator's being all weird.
So, what are you doing? Looking for what? So I got 0.118 if we go out to 3. Is that what you got?
I'm sorry, I'm still trying to. My calculator's not cooperating. I can't see anything on the screen. It looks funny.
Okay.
There's lines going everywhere. So, let me just pull out this other one. What did you say you got?
0.118?
Okay, that's also what I got. I got a -0.1.
Yeah, that's what I got. Was negative.
Okay.
0.18. Sorry.
Oh no, you're good. It's same thing, just different sides of the thing.
Yeah. And then degrees of freedom, I got 14.
Uh-huh.
Okay. Just sample size minus 1, right? Just making
Yeah.
sure I understand.
Oh, I understand. Sketch the t-distribution and shade the area which represents the p-value.
Okay.
Do you know how to do that?
Let me take a look. I don't. But degrees of freedom, you do want. I'm making sure I understand. Is sample size minus 1, right?
Yeah. So does this movie talk anything about that?
Yeah, I'm gonna do that. And it says use your software to compute the p-value. Did that pop up here somewhere? Maybe I don't know.
Um, I don't know.
I don't know how I would use the software to get the p-value. Does that show up on the?
Okay, so the t-distribution or degrees of freedom would be 14. It does look like it shows up on there, yeah.
Mm-mm. Mm-mm.
It's actually not just drinking the cup of tea. She got out the pineapple stuff and the coconut.
Zach, put that stuff back, please.
We already squeezed some of the gel stuff into
Let's see.
Might have figured it out.
Okay.
I figured out how to get the... Yeah, I didn't. Oh, that didn't tell me what I wanted to.
Yeah, I'm not seeing. Statistics, explore, statistics. Okay.
What did you get for your T value again?
T, I got the negative 118. Right?
1.18, right?
0.118.
0.118? Okay, I did it wrong then. Oh, no, I didn't. I just read my calculator wrong. Whoops, okay, yeah, I did figure it out on SPSS. I think. Or at least I'm on the way to. So that's how you find the T value. And then the P value.
Okay. Where do we see that at? Or do we have to enter it somewhere?
It uses... I think we just look at it. I'm not 100% sure though. I'm trying to absorb all of it from... Never mind.
Did you find it, or?
No, sorry, I just got a call from one of your young men. So I was going to answer that, but then I missed the call, so I'll just call him in a second. I feel like we're close. I'm just going to check the, see if I can figure something out from his video.
From the Maths department. This is supplemental video doing the SPSS plans for interactive. And also cover the ones that SPSS. And then finally, right so start off with how we're doing throughout this is use the so for instance, if I want to do these I'll take the products and if I want to, you can actually do a comment interval. You can press a little comment, so I won't worry about that. So, also, and files as well too. And maybe there's a class that I'm watching videos I also think it's the amount of tests like that is pretty that's the requirements. Also, there's this as well as how it is. The requirement that's how massive. Second thing, that's so that's subject of this hypothesis. But the null hypothesis criteria is right. That's what the null hypothesis says. Now you also obvious here. But probably any of the results are just as because it's like this. However, this is one side test. This case, we're supposed to
I think I might have found it.
Okay.
However, this is the one-sided test that we have to divide this number in half in this case. We're supposed to however, we can't really do anything for this right here. We're going to get confidence.
Our confidence interval on this is 95.
Okay.
Right?
Right.
Okay. So in that one sample test, there's a box that says sig two-tailed, and just from what I gleaned from the video is that is our p-value. Let me just check and make sure that is what I'm thinking. Hypothetically, that's what our p-value is, but that's not what it says on the key.
Okay, where are you seeing this?
Seeing which?
This two-tailed or whatever you said.
Did you pull up the t-test on SPSS? Let me walk you through how to do that.
Okay.
So you just go up to Analyze and go Compare Means, and then one sample t-test.
One sample t-test?
And then just make sure that your column is over there, and then in test value, that's going to be the null hypothesis. And so we just want it to be 47 in this case.
Okay, I get 0.000 on mine. That's not right.
I got nothing.
Let me see. Compare means. And one sample t-test?
Uh-huh.
Okay.
And then variables over there. Maybe check your options and see if what your confidence level is, or your confidence interval.
That's 95.
And then the test value, do you have 47?
Yeah. Oh, okay. Where do I put test value in that?
Test. It's right underneath where you have your test variable.
Oh, test value, 47. Okay. Okay, now I have 0.909.
And that's what I have too, and that's...
We have 0.9077.
Yeah. It also says on the key that they got, for the t value, that they got 0.188, but on the program it says 0.177. So this is just me, but I think we should just go with it.
Okay.
Because
Shall we try the quiz then?
I just want to go over F real fast.
Okay, well,
Question. It's just
Okay.
about do you reject the null hypothesis or fail to reject with the 0.05 level of significance? And because our p-value is greater than our level of significance, we fail to reject. Is that right?
Right. Right.
Okay. All right. Yeah, that's all I wanted to check on.
Okay.
But let's go for it. If you're up for it, I'm up for it. And
Okay.
what's the worst that can happen?
Okay, 1, 2. Let's see. Are you in?
I just am starting now. And yes, I'm in.
In previous lessons, we've assumed the population standard deviation was known. In this lesson, we are making a different assumption about standard deviation. What has changed?
Well, we assume it is unknown.
Yep.
Okay, the null hypothesis is that population mean is equal to 8, and the alternative hypothesis is that population the population mean is greater than 8. The population standard deviation is not known. Becker collects a sample size of 9 and computes a mean of 11 and a standard deviation of 6. Is sigma known? No, it's not. The value of t. Well, I'm going to figure it out on the calculator because we use SPSS. It's not. Actually, we can't use SPSS with that. I got a t-value of 1.5.
That's what I got too.
Okay.
Should we go with it?
Yep.
Okay. So I guess we have to put these into SPSS. Is that what you're getting?
Yeah. I'm gonna see if I can if there's a way to do this faster though. Might not be, but there might be. If you just highlight the column, like if you just highlight all of from just all of that data right there, and then just copy it, and then select one of the cells in SPSS and say paste, it'll just paste it all in.
Okay.
So that's good.
Yay!
I know, right? That would have been nice to know a little bit ago. Okay, and in this we're going to need the sample mean, standard
What is
deviation,
x?
and the t.
Okay, so x string variables. What?
String variable?
What did I do? Okay, so x is going to be 98.220, right?
Yes. And then the standard deviation I got was 0.922.
Yes. T-score. Okay, how do we do that again? We went to...
So go to Analyze and Compare Means and one sample t-test.
Okay. And our test value is 98.6, right?
Yep.
Oops, that would have been bad. Yeah, 908.6. Negative 1.843.
Let me... Yeah. And now, with the sig on this one, I think that we have to divide that in half because our alternative hypothesis is one-tailed, and the sig that they give here is two-tailed. So in order to get the p-value, we just need to divide the 0.01 or 0.081 in half. And that gives us our p-value, I think.
0.041.
Uh-huh.
Okay. What is our level of significance?
0.05. So
if we do that, we would reject the null hypothesis, right?
So yeah.
I don't know. That's...
I didn't even read what all of what it said. It's just giving us data.
I'm going to try that. I'm going to go with the 0.081 and fail to reject, and we'll see what that does.
Okay.
Because I don't know.
Well,
Okay.
okay, so for the next one, we just do the same thing with that other data, but we just need to find the p-value and then make a decision. And for that p-value, I got 0.995.
So we're analyzing against 40, right?
Mm-hmm.
.995.
Yep.
Okay, and
For this one, because it's only one-tailed, we would take that, our p-value that we just found, and just divide that in half.
so we're dividing the .995 in half.
Uh-huh. And see, that's what I was thinking we do with the p-value on the last one, because instead of it asking for it to be not equal, it was less than or it was greater than, which makes it just one-tailed. And then 14, if we do it this way, then
Okay.
our... Sorry?
Wait, okay. So we are rejecting the hypothesis or failing to reject?
I believe we'd fail to reject because our level of significance is 0.01. And so our p-value
Okay,
is
yes, it's
higher. Right.
And if we do that, it's going to do 13. It's going to decrease, right?
Yeah. And on that one, again, I think it's the same thing. We fail to reject because it's still going to be above 0.01. And then the confidence intervals, I think, are going to be the same. What do you think?
I think they're going to be the same too because we're not changing anything there.
Uh-huh.
Shall we submit it and see?
I guess so. Submit and... Sweet. 100%.
Yep. And I got an 88 because I went the other way on those two, on 9 and 10. So you were right. Alrighty.
Okay, thanks, Bernie.
All right. We'll see you next week.
All right, have a great weekend.
You too.
All right.
Bye.
Bye bye.